Okay, it's chapter 9, section 5. Getting close to the end of the year. Not much longer now. This is good stuff. Little recap if you had to do a problem like this, didn't want to use your calculator or weren't allowed to. Sine of 225, first thing I do is I go over here, quadrant 3. If I was chilling in the STC, I know that sine is negative in quadrant 3. Positive there, negative over there. I know my answer will be negative. So I got sine 225 equals negative. 225 gives me a reference angle of 45 degrees. Grab my 45, 45, 90, 1 square root 2. Sine is opposite over hypotenuse, 1 over the square root of 2. What if you're in one of those spots that doesn't allow you to have a square root on the bottom? Multiply the top and the bottom by the square root of 2. Boom, done. Good stuff. Period. How long does it take to get back to where you started? How long does it take to get back to where you started? Or in this case, how many degrees? I start here, go up at a slant, come down steep, go up deep, go back down. Ooh, looks like that's my starting point because from there to there, I did up, down, up, and then down slightly. Now I'm going to start over again. And then I'm going to go up, down, up, and I'm going to get back there. So I do two of them in 3 pi. So the period here is going to be 3 pi divided by 2. It's almost like 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2. That's how we know that the period, how long until I start over again, okay? That's what we're looking for in terms of what is the period of the function. So if you're talking about a year in months, you would be talking about 12 months would be our period. Okay. What if x is a positive acute angle and the cosine of x is 7/9? What is the exact value? Exact value very important because most of you could probably put something into your calculator, figure it out, and go from there. But we're talking exact values here. Okay, so we're talking about drawing a triangle from angle x where the adjacent over the hypotenuse is 7/9. And then you're going to need to do 81 minus 49. C squared minus a squared, something like that. So this is going to be the square root of 32, which is 4 root 2. So now if you're talking sine, you're talking opposite over hypotenuse. So sine of x would be 4 root 2 over 9. Never found the angle. Didn't need it, did I? No, I didn't. Okay, here we go. We're going to graph the sine functions here. So the first thing we're going to do is I'm going to grab my calculator and we're going to fill these in pretty quickly. So I'm going to go to y equals, and I'm going to go y equals the sine of x, and we're going to see some patterns, all right? Now we're going to look at the table. But before I look at the table, I'm going to set my table, and I'm going to say my table start is going to be 0, and I'm going to count by 30 degrees, okay? I'm going to count by 30. I could count by 15, I guess, but yeah, we can count by 15. Sure, why not? And now when I look at the table, I'm really focused on 30 is 0.5, 45 is 0.707, 60 is 0.866, 90 is 1, 120 is 0.866. We can get those off your calculator. Leave those there for you. And then let's fill a few things in here and see what we're talking about. Okay, so sine of 0 off of there should have been 0. Oh, look at. Can we just think about our 30, 60, 90s? 1, 2, square root 3. And then could we think about 45, 45, 90s? 1, 1, square root 2. And if I think about the sine of 30, it's a half, which I got on my calculator there. Sine of 45, 1 over the square root of 2, or square root of 2 over 2, that is 0.707. I'm going to take my word for it, or look at your calculator. Sine of 60, square root 3 over 2 is 0.866. Okay, sine of 90 is 1. We get that off the calculator. And then we go over to quadrant 2, and I'm going to do 120, which is a 60-degree reference angle in 120. Well, 60 is still 0.866. 135, that's a 45 in quadrant 2, 0.707. 150, that's a 30 in quadrant 2, that's 0.5, and 180 is back to 0. And now we go to chilling in the STC. So it's like all of these ones for sine over here have got to be negative, because in quadrant 2 and quadrant 3, or quadrant 3 and quadrant 4, my sine is always going to be negative. So let's think about what this is. This is a 30-degree reference angle. I'm down to 0.5. And then it's 45, 0.707. 240, 0.866. 270, that's negative 1. 300, that's 0.866. That's a 60-degree reference angle in quadrant 4. And then 0.707. And then 0.5. And then we're back to 360, which is coterminal with 0. So I'm going to be at 0. Okay, so what we're going to be talking about when we're graphing these things is, where do these things occur on a coordinate plane? If this is the theta and this is the y, or the sine theta, the value that you get after you get it, if you think about going to 1 and then a 0.5er and then a negative 0.5er and a negative 1, you know, I start out at 0, and I kind of like to do this like this, and I'm going to show you this. This is a fast way to graph. I don't use graph paper for these. I think this is a much better way to do it. And if we think about it, I could go graph all of these points individually, but let's get that 0, that 1 at 90 degrees, back at 0 at 180, back at negative 1 at 270, and back at 0 here. And then watch what happens in between. 30 degrees is 0.5, and then it's 0.707 and 0.866 and 0.866 and 0.707 and 0.5. And look at how wonderful, and boom, we can sketch a graph. So we're not plotting all these points, are we? We're gonna put them on our coordinate plane like that, and we're gonna be able to, if you can find these 5 important points and you can understand what a sine curve looks like, that's what it looks like. Okay. Now I'm going to change my pen color, and I'm going to go with blue, and we're going to do cosine. So if we go back to our calculator, if you type cosine and look in there and look at your table, you get 1, and then I get cosine of 30. That's square root 3 over 2, 0.866. And 45, that's where sine and cosine are the same. And 60 is actually 0.5. So the cosine of 60, 1 over 2. 90 is 0, cosine of 90. Cosine of 120. Now oh, wait, what happens to cosine in quadrant 2? Chilling in the STC. Cosine is negative. This is negative. Oh, we snuck into negative land there. Negative 0.707, negative 0.866, negative 1, negative 0.866. I'm in quadrant 3 now. And then negative 0.707 and negative 0.5. And then I'm back to 0. And then I'm positive in quadrant 4, and I'm positive a half, because 300, that's a 60-degree reference angle in quadrant 4. Cosine is adjacent over hypotenuse. And then I get positive 0.707, and then I get positive 0.866, and I'm coterminal back with 0, which means I'm at 1. So this one, we start up here, and then at 90, we're at 0. At 180, we're at negative 1. At 270, we're at 0, and I'm back to where I started. And if you think about what's happening here, this is what my cosine graph looks like. And that's one period. The period of sine and cosine is 360 degrees. So take a look at this. Where are these intersections occurring? They're occurring at 45, because 45 is isosceles, isn't it? And we're occurring at 225. 225, that's an isosceles triangle. So I got negative 0.707. And really, this whole thing, if I shifted this 90 degrees to the right, or if I shifted the sine 90 degrees to the left, then we'd be on top of one another. Okay, so you need to focus on the fact that the sine starts at the origin and then runs its course, and you need to focus on the fact that cosine starts at its maximum and then runs its course. And this is all we're going to be focusing on graphing here in Algebra 2. We're just going to graph one sequence. Sometimes we'll graph two just to see how it looks. Okay, so let's look at your calculator again, because I want to see what that does for a graph. If you were going to graph the sine curve on your calculator, you got to think about going from 0 to 360 degrees, right? Because I'm in degrees. My mode should be in degrees. X's, I'm going to show you up to 3, I think, or scale, excuse me. Let's count by 30s. Let's count by 30s. That's my degrees. My Y's are my values. So I'm going to go from -3 to +3, and I'm going to count by, let's count by halves so we can see the tick marks. So my degrees are going from 0 to 360, counting by 30s. My Y's are going from -3 to +3, counting by a half. So now when I take a look at the graph, I can see it. And if you think about what this means here, this is going to be 0, 30, that's a half, 60.866, 90 is 1, 120.866, this is 150. So I didn't put the 45s in there, but you get the gist of it. So this is the sine curve. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Chilling in the S here, everything's positive in quadrant 1, S, T, C. So you can kind of see these on here. And now let's go, I'm going to graph the cosine on here as well. Cosine of x, and if I look at that graph, look at how it starts at its apex, passes through 0, bottoms out, passes through 0, goes back to its apex. And that is how we're going to look at the graph of sine and cosine. All right. So this is good stuff. I love this stuff. Great stuff. Yep, we did it. Yep, great. Okay. A cycle is going to be how to get through the whole pattern. So I'm going to go through my pattern here. And this one is starting here, going through, ending here. One complete pattern. Period is how long it takes. In this case, it's 360. Amplitude, half the distance from the max and the min. It's 1 in this case. It's from this midline, I go 1 unit up, and from this midline, I go 1 unit down. So sometimes we average top and the bottom, but we can clearly see 1 up, 1 down. That means the amplitude is 1. Amplitude is height, so it's how high are we going. Okay. So the period is 360. The range goes from -1 to +1 included. Domain is all real numbers. Amplitude for both of these is 1. This thing at the bottom, you got to pay attention right now. We're going to move these things. So, whoa. What happened there? I don't know what happened. I don't know what happened. Stick with me. Here we go. It's almost like nothing went wrong. Okay, here we go. So we're going to talk about these down here. The coefficient in front is the amplitude. We always speak the amplitude in positive numbers. So if it's negative, if it's -3 sine theta, your amplitude is still 3. It just means that the negative means instead of starting and going up, we start and go down. It's a reflecting over the x-axis. That shouldn't be groundbreaking. And then here's the big one. Period is 360 divided by b. 360 divided by the number in front of that theta will give you the period. And that's how long it will take you to get from start to finish. So when we just write this one, the A is equal to 1, and then the B is equal to 1 for both of these. That means that the period is 360 divided by 1. That's why we get done in 360 degrees. Going to be very important. Okay, so there's our form. Y equals A sine BX is the same for cosine, and the period is going to be 360 divided by B. So if I was going to do this one, find the amplitude and the period. All we're going to do is going to take a look at A is equal to the absolute value of 1. The amplitude here is equal to 1. Boom, got it. Piece of cake. There's a number in front of it, that's the amplitude. Amplitude is the easiest thing that we will find. Amplitude and vertical shift. Vertical shift, that'll come up tomorrow. The value of B is 1/3. So this is the big one now. Period is equal to 360 divided by the value of B. Well, what is 360 divided by 1/3? Flip the second guy and multiply. That's going to be 1080. That means to get through up, down, up, it's going to take me 1080 degrees to get done. So the 1/3 makes it go slower. Okay? Very drawn out. All right? That's going to change things when we go to graph it. Okay. So amplitude is 1, period there is 1, 1080. Sine again. So we're going to go the amplitude here. There's a 2 there. Amplitude is the absolute value of 2, so the amplitude is 2. And then I get a half. That's going to be the period is 360 divided by a half. Flip the second guy and multiply. The period is 720. Okay, so if I was going to graph this one, which is what we're going to do here in a little bit, I'm going to put an ending point of 720. I'm going to put a halfway point of 360. I'm going to put a quarter marker and a quarter marker. Okay, so 720 is the end, 360 is half of the half. What's half of a half? A quarter. And then I go 1, 2, 1, 2. Okay, and I like to put boundary lines in there, kind of like we're graphing, or you're writing your capital letters as a third grader, something like that. And I know sine starts at the origin, maxes at the quarter, back to the origin at the half, minimum back here, boom, we've graphed it. Period is done in 720. Normal one would have looked like this. Let me change that pen color. If I had graphed a normal one, magenta. If I had graphed the normal one, it would have been at 90, and then it would have been here, and it would have been here, and it would have been back, and it would be real quick. So you can see the half slows it down, and the 2 makes it taller. And then I could go again. It also, the half, it's going half as fast. That means I can get 2 of them done. With the other ones, I would get 2 done in the time it takes me to get 1 done. Good stuff, good stuff. Okay, graph the function. It's a cosine. It's a cosine, people. Be careful. I got an amplitude of 4. I have a period of, you got to understand, it's 360 divided by 3. That's 120. So if I'm graphing this one, I'm going like this. 1, 2, 3, 4 up. 1, 2, 3, 4 down. And then I'm going to get done in 120. Half of 120 is 60. Half of a half, 30. And then I can figure out that 90 would need to go there. So these are great to write like this. Here's my maximums. Here's my minimums. Here's the thing, people. Here's the thing. Cosine, you got to pay attention. Because where does cosine start? Does cosine start at the origin? It does not. It starts set as maximum, and then it goes to 0, and then it goes to minimum, and then it goes to 0. And you're going to follow that each time. Each time you're going to follow that pattern of the original one. Again, this one's getting done really fast, because if I had a normal one on here, I would have gone all the way to, this would be 120, this would be 240, this would be, 320, 360 would be all the way over there. And really, we would have been at something like, I think it would go like this. We would bottom out at 180. Oh, that should be 270, sorry. Oh, kind of sorry. It'd be done. Oh, wait, we would be down here. Oh, geez. What am I doing? It'd look like that, right? Because we wouldn't go all the way up. We would stay down. So the green one is my focus here. Max, max, min, 0, 0. Focus on that. Focus on that. Let's look at that on the calculator real quick, just to make some comparisons. So I got y equals, and I think I had 4 cosine, and then it was what was it? 3x. Okay. 4 cosine 3x. And let's compare that to the regular cosine x. But I need to think about my window a little bit, because my negative 4. So let's go negative 5. Whoa, 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 whoa. Negative 5. And let's go to 5. And let's count by ones. Let's see, what am I doing here? 0 to 360 by 30 degrees, negative 5 to positive 5 by 1s. Let's graph this now. There's that quick one, huh? There's the one and there's the regular one. So the regular one gets done here. The regular one gets done in 360 and has an amplitude of 1. And then this is the one with an amplitude of 4, up 4, down 4. And look at, boom, done. There's 120. 30, 60, 90, 120. Done. Back to where I started. Another 30, 60, 90, 120. Boom, done. 30, 60, 90, 120. Boom, done. I do 3 of them in the time that it normally would have taken me to do 1. And then I have got, the regular one right there in the red. So good stuff. Love this stuff. Loving it. Loving it. Loving it. Graph. This one's even easier, except now the amplitude is going to be a half. So if I was graphing this one, I'd still make the half go a little higher and negative a half. And then I'd be done in 360, because I know my period is 360. And there's my 180, and there's my 90, and there's my 270. And I know it's starting up, bottoming at 0 and coming back up. I'm coming up, so you better get the party started. So that's all you got to do. Identify the amplitude, identify the period, sketch the graph, use what you know about period in order to help you with the graph. Okay, good. Okay, here we go. Amplitude of 1/3. What a terrible problem. This is a terrible problem. I'm not sure who made this problem. Amplitude of 1/3. Now, if I was graphing this on a normal, it'd be so small. So that's why I like to just graph. At this stage of my graphing career, I like to just graph my own and make my own scale. And then I've got this 360 divided by 2 for the period. Remember, period, 360 divided by b. That's 180. That means I'm going to be done in 180. 90 is a half, 45, 135. It's a sine. Start at the origin, max, back, down, back. Every time, people. Every time. You want to do another one? 360, 270, what is this? 225, 315. You go again. You go up, middle, down, back. You can do it again. You can keep doing it, because the sine curve goes forever. The domain is negative infinity to infinity. All right, which is which? Okay, I identify an amplitude of 3. It has to be this one. We're done. Look at how fast that is. 1, 1, 1/3. Doesn't matter. Period here would be 360 divided by 2. There it is. It's that one, because I go from max to max. Yeah, love it. Love it. Okay, last thing for today, frequency. So period, we already talked about that. Amplitude, how high do we go? Vertical distance from the middle of the max or the min. Frequency, look at, before you freak out about frequency, don't do that. Because look at, I tell you what, the frequency, the reciprocal of the period. So it's cycles per minute instead of minute per cycle. Okay, so we're going the other direction. So if I know that I have a period of 360 degrees, then my frequency is going to be 1/360th of a degree, all right? And that's going to come up in sound waves, which we're going to take a look at right now. It says humans can hear sounds with a frequency of 40 hertz. Find the period of the function that models the sound waves. Okay, let's not make this harder than it needs to be. If my frequency is 40, then my period is the reciprocal, or 1/40th, okay? 1/40th, the reciprocal of the period. So how do we graph something like this? It says use an amplitude of 1, and it says graph a sine curve, and we're going to use this period, okay? We're going to use that period. So I'm going to do, we got to write the function first of all. Okay, this is a big moment. Pay attention right now. Period. How do you find it? 360 divided by b equals 1/40. Okay? Period is 360. Now we got to solve for b. Cross multiply. b is equal to 360 times 40 divided by 1. 14,400. 14,400. So my equation is y equals, they said amplitude was 1, sine of 14,400 t. This is a time, okay? And now how do you graph this, okay? We graph it. We get done in 1/140th. You can't see. This is going to be like a sound wave that's going to look like this, right? It's going to go so fast, right? So here's how I do this. Cut that in half. It's 1/80th. Cut 1/80th in half. It's 1/160. I did not draw this very well to scale. Okay, we're doing the best we can. Here, I'll give you a trick now. Here's a trick. So pay attention. 1/160th, 2/160ths, it simplifies. This has to be 3/160ths, and this is 4/160ths. You see that? That's a great way to find that one, because otherwise people are like, what's going on? 1/160th, 2/160th, 3/160ths, 4/160ths. It's just those two are simplified. And then it said sine, so we start, we max, we zero, we min, we max. Or we zero, excuse me. And there's your wave. Now, 1/140th is going to go really fast, but we can't draw that. So we just draw it out and we label our axis. Got to label your axis. Same thing here, except this is 50. It's exactly the same thing. So I'm going to do 50. I'm going to do 50. I don't want a pen color. I want a pen. 50 is the frequency, which means 1/50th is the period, which means the period is equal to 360 over b. If you're doing it in degree, oh crap! I forgot to tell you. All these should be. This should be 2 pi. I should do this in 2 pi. I'm gonna erase this. Let's do this one. You should do all your word problems in radians, which is 2 pi. So let's do that, because that's where that 14,400 is a little bit big. So I get 50 for the frequency, and then I get 1/50th for the period. And now each period is 2 pi over b. So watch now. Cross multiply. What do I get? I get 100 pi, right? 100 pi. So when I write the equation, they want a sine curve. Y equals sine 100 pi times t. That's your value of b. Now your period is 1/50th. Again, 1/50th, cut it in half, 1/100th. Cut it in half, 1/200. Trick, 1/200, 2/200, 3/200. Sine starts here, max here, min there. Boom. Ain't it great to be crazy? We're done. All right. That wasn't too bad. You got to remember 360 over b for that period. That's the one thing that people forget about.